we are going to discuss on the three-phase system, and first we have drawn all the phase voltages VA, VB and VC, which are 120 degree apart. Now we need to draw the line to line voltages. It is VAB. So VAB is nothing but leading your phase voltage, corresponding phase voltage by an angle 30 degree. So here you can see the difference. VAB is leading VA by 30 degrees. So in the similar fashion you need to draw VBC, VCA, and also you need to draw the waveform for VBA, VCB and VAC. So in order to have a discussion on the three-phase rectifier circuits. Now we have drawn all the three line voltages VAB, VBC and VCA. The similar fashion we will be drawing VBA, VCB and VAC in order to complete the three-phase waveforms. Now we have all the three-phase waveforms which you have marked over here. So it is VAB, then VAC, VBC, VBA, VCA, VCB, and again it is continuing. And we have also marked the EMF E because the load is also having, it is an RLE load, so we have marked the E also. And now we will be discussing on how we are going to trigger on the each of the thyristors in order to get different average output voltages in the case of a three-phase control rectifier system. Now we are going to discuss a three-phase full converter with an RLE load. We are having 6 thyristors from T1 to T6. The positive group of thyristors or the upper half thyristors are T1, T3 and T5, and lower half thyristors are for negative group are T2, T4 and T6. So the naming convention of the thyristors are T1, T2, T3, T4, T5 and T6. And we are connecting the three-phase supply ABCs to the input, and we have our load. It is an RLE load, and the voltage V0 is the output voltage across the load. So here the firing sequence of the thyristors are T1, T2, T3, T4, T5 and T6, and again repeating starting from T1. Now the positive group of thyristors are fired at an angle of 120 degree, and negative group are also fired at an interval of 120 degree. So between the positive group and the negative group, they are fired at an angle of 60 degree. So that means each thyristors are conducting for 120 degree, and the firing sequence between the thyristors is in such a way that if one thyristor is fired from the positive half at certain angle, then from the lower half it will be fired after 60 degree, and from the upper half thyristors the second thyristor will be fired at an interval of 120 degrees, and that will be repeating. Now we need to identify the value for alpha equal to 0 degree, that is the firing angle alpha equal to 0 degree. So we have drawn our reference waveform with VA as 0. So VA is the reference waveform at omega t equal to 0. So VA, VB and VC. And therefore alpha equal to 0 or firing angle equal to 0 is indicated by omega t equal to 30 degree. So omega t equal to 30 degree is corresponding to the firing angle alpha equal to 0. So now we have already marked the corresponding firing angle referring to the 0 degree for each sequences. So here you can see that it is alpha T1 equal to 0 after 120 degrees, that is 30, 60, 90, 120. So the positive half After 120 degrees you have the alpha T3 equal to 0. Again after 120 degrees you are having the alpha T5 equal to 0, corresponding to the firing angle of alpha equal to 0 degrees. Now from the lower half thyristors, alpha equal to 0, we have already discussed that the lower half thyristors are fired over 60 degree with respect to the upper half. So after 60 degree you are referring to alpha T2 equal to 0. Again after 120 degrees alpha T4 equal to 0. Again after 120 degrees alpha T6 equal to 0. Now we are going to plot the output voltage corresponding to the firing angle alpha equal to 0 degrees. So here we are finding out V0 for alpha equal to 0 degrees. Now we need to find out which thyristors are turned on at each instances in order to plot the output waveform. Now we will be plotting the sequence of firing of the thyristors. For alpha equal to 0, the corresponding thyristor which is fired is at this particular instance referring to alpha T1 equal to 0. So this is for the instant of thyristor T1. Once thyristor T1 is fired from the positive group, from the negative group the next thyristor is to be fired at after 60 degrees after the instant positive group is fired. So after 30 plus 60 degrees you have to fire the thyristor T2, and from the upper half it will be running for 120 degrees, so 30, 60, 90 and 120. The next set of positive group is T3, so T3 is fired, and after 3 is fired, after 60 degrees lower half is fired, so it is T4. Now you can repeat the sequence. So this will continue for 120 degrees, then T5 will be there, 1, 2, 3, 4, 120 degrees. Now we understand the firing sequence of the thyristors. So we will start from here. So when T1 and T6 are conducting, so during this period when T1 and T6 are conducting, we will see which voltage is coming across the load. So it is T1 and T6. So the current flow will be from A, T1, RLE, T6 and back to the B, and therefore the voltage which is coming across the load V0 is nothing but VAB. So that VAB we will plot it here as the output voltage. So this is VAB. Now from the lower half thyristor T6 was commutated at this instant and T2 starts conducting. So that means T1 and T2 are conducting. We will see from this figure when T1 and T2 are conducting, the voltage will be A, T1, RLE, T2 and C. So the voltage is coming across the load is nothing but VAC. So that VAC we will be plotting it over here. This is VAC. Now since T1 has conducted for 120 degrees, T1 is commutated and T3 comes into picture. Now the conducting thyristors are T3 and T2. We will see from the figure when T3 and T2 are conducting, it is from the point B, T3, RLE, T2 and the point C. So the voltage which is coming across the load V0 is nothing but VBC. So therefore I can plot the load voltage as VBC. Now again T4 comes into picture. Now T3 and T4 are conducting. When T3 and T4 are conducting, the current flow will be from point B, T3, RLE, T4 back to A. So the voltage which comes into picture is nothing but VBA. So the corresponding VBA over here we can plot. So now you can complete it from this side also. Therefore, in the case of a three-phase full converter with the RLE load, the output voltage for firing angle alpha equal to 0 is nothing but this particular waveform. So the sequence of firing of thyristors is as mentioned here. If we are naming the thyristors in such a fashion T1, T2, T3, T4, T5 and T6, then you can see that it is from T1, T2, T3, T4, T5, T6, and again the sequence is repeating. So now we will see how it is going to happen for alpha equal to 30 degrees. Now we are going to plot the output voltage for firing angle alpha equal to 30 degrees. So when alpha equal to 30 degree, T1 is fired at omega t equal to 30 plus alpha. This 30 comes into picture because we have taken the reference value of the phase voltage as VA. So therefore at omega t equal to 60 degree, you need to fire your thyristor alpha T1 equal to 30 degrees. So now actually this was alpha T1 equal to 0. Now the firing of the thyristor will be happening after 30 degrees from omega t equal to 30. So it is at omega t equal to 60 degree you are going to fire your thyristor T1. So that means at this instant I am going to fire thyristor T1. So in the same way what we have discussed in the earlier case, it will be conducting for 120 degrees, and also the next set of thyristors from the lower half will be fired after 60 degrees. So at this instant T2 comes into picture. Once you have marked these two things, now it is very easy. 120 degrees, 1, 2, 3, 4. So now T2 will be conducting for 120 degrees. So now T3 comes into picture. Then T4, then T5, and T6. So here it is T2, T4 and T6. So again here T6 comes into picture. And here it is T1, T3 and T5. So here again it is T5 here. So now you can compare these two things. That is for alpha equal to 0 degrees and alpha equal to 30 degrees. You can see that there is a shift of angle by 30 degrees. Because this was our reference waveform. Now we are going to plot the output voltage corresponding to alpha equal to 30 degrees. So now we have seen that at this instant you are going to fire your thyristor T1. So T1 and T6 are conducting. So now we will see it over here. When T1 and T6 are conducting, it is A, T1, RLE, T6 and point B. So the corresponding voltage which comes across the load V0 is nothing but VAB. So therefore we will be plotting the waveform of VAB from during the time when T1 and T6 are conducting, that is from this particular point to this instant. So here T6 is commutated and T2 comes into picture over here. So when T1 and T2 are conducting, the corresponding voltage is A, T1 RLE, T2 and to the point C. So VAC is coming across the load voltage V0. So now you need to plot VAC. So that is nothing but this particular waveform. So this from here till here, it is VAC. Again at this instant T1 is commutated and T3 starts conducting. So T3 and T2 are conducting. So during that instant of time, we will see from the figure, it is from the point B, T3, RLE, T2 to the point C. So the voltage which comes across the load V0 is nothing but VBC. So we will see from here, VBC waveform is nothing but this one, that is from this instant to this particular instant. Now we will repeat it for the rest of the waveforms. So now this is the waveform which is corresponding for the output voltage when alpha equal to 30 degrees. Now we will see it how to draw it for alpha equal to 60 degrees. Now we will see output voltage V0 for alpha equal to 60 degrees. So alpha equal to 60 degrees means T1 will be fired at omega t equal to 30 plus 60, which is indicating 90 degrees. So T1 is fired at 90 degrees with respect to the 0 point. So now we can see here it is 30, 60 and 90. T1 is triggered. So the set of sequences will be T1 and T6 will be conducting. So it is VAB, then VAC, then VBC, then VBA, and the system will be continuing. Here I have not mentioned the thyristor firing sequences, which you have to plot it by yourself and understand how we can plot the waveform. Now we will plot the waveform for voltage V0 for alpha equal to 90 degrees, that is firing angle alpha equal to 90 degrees. So when firing angle alpha equal to 90 degrees, then the T1 is fired at omega t equal to 30 plus 90, that is 120. So 30 is because our reference waveform we have taken as the phase voltage VA as the reference waveform. Now coming to here, you can identify that 30, 60, 90 and 120. So here I am going to fire the thyristor T1 and T6 was still continuing, which we came to know from the previous firing sequences. So now the waveform corresponding, so when T1 and T6 are conducting, you can see it over here. It is VA, T1, RLE, T6 to the point B. So VAB comes into picture. So therefore we have to plot the corresponding three-phase waveform corresponding to VAB. So this is nothing but VAB. So here I am going to fire the thyristor T1 and T6 was still continuing. So this is for VAB. Next T1 and T2 comes into picture. So T1 and T2 voltage is VAC. So the corresponding waveform after VAB we have already mentioned here, VAC is coming. So therefore in this, after VAB, VAC is nothing but this one. So from here to here I can plot VAC. Again the next set of thyristors comes into picture and you will get it for VBC. So this is how it looks for alpha equal to 90 degrees. The average output voltage is 0 because on either half you can see that the area is the same, and this is the firing sequence of the thyristors. So far what we were discussing is for alpha less than 90 degrees. So in the earlier case when we were discussing in the single phase system, we have discussed about the line commutator inverter when the firing angle alpha is greater than 90 degrees. So that is going to apply it over here in a three-phase system. When we are having alpha greater than 90 degrees, this is going to act as a line commutated inverter. Now we are going to find the output voltage for firing angle alpha equal to 120 degrees. So that means T1 get fired at omega t equal to 30 plus 120, which is equal to 150 degrees. So we will see it over here. I have plotted down the waveforms and noted down the corresponding waveforms. So here it is 30, 60, 90, 120 and 150. Here I am going to fire thyristor T1. It will be continuing for 120 degrees. So once thyristor T1 is fired, after 60 degrees, I need to fire thyristor T2. Now the entire firing sequence of thyristors, I have mentioned it over here. So at this instant, T1 and T6 are conducting. So we can see it from this figure. When T1 and T6 are conducting, the voltage which comes across the load is nothing but VAB. So T1 RLE T6 to the point B. So the corresponding waveform of VAB I can mark as the output voltage. So the next set, T1 and T2 are conducting. So that means T1 and T2 voltage corresponding, it is VAC coming across the load RLE. So therefore VAC is nothing but this waveform. So I will plot like this. Next set is T2 and T3. You can see it from here. T2 and T3, the voltage coming across the load is VBC. So T3 RLE T2 and point C, it is VBC. So the corresponding waveform, it is VBC over here, and in that I can mark this. Now this is the output voltage for alpha equal to 120 degrees. So this is corresponding to VAB, VAC, VBC, VBA, like that. Now in all these cases, one thing we need to remember is that the load current I0, we have assumed it as a constant value. And if you are asked to plot the I0, you can draw the load current in such a fashion that is a constant value. Now here you can see that when V0 has become negative when your alpha is greater than 120 degrees, because this is the 0 point. So effectively you can say that this is going to act as a line commutated inverter, which is going to give back the supply. So the current direction will be the same, but effective power becomes negative. Why? Because the average output voltage V0 has become negative. Thank you.